agreement's not to cross each other's lines, but yeah.
Yeah, T10 beetle clouds. P6 beetle.
P6B is nice because it's not satellite based. I think, isn't T6B WiMAX?
T6?
Yeah, T6B, provider.
Yeah, WiMAX. Yeah, WiMAX.
It's actually using
Okay, is everybody getting some stuff there? All right, Nick, it's all yours. Go ahead.
Alright, so I'm doing my presentation on malicious code. And the definition of malicious code is any code in any part of the software system or script that is intended to cause undesired effects, security breaches, or damage to a system. There's a whole bunch of different types of malicious codes. I'm only going to be going over a few of them, such as viruses, worms, Trojan horses, trapdoors, and a few other ones. A virus is a piece of code that attaches to a host program and reproduces when the infected program is executed. There are over 10,000 known types of computer viruses, which is pretty crazy. And it's even crazier that about 200 new computer viruses are found every month. That's a lot of viruses. A few different types of viruses. There's file deleting viruses, which are designed to delete critical files, which could be part of operating systems or data files. Polymorphic viruses, which are capable of changing their appearance and changing their code every time they infect different systems, so that they can. It makes it harder for them to be found. Stealth viruses are kind of the same, not really. They're capable of hiding in operating systems or hiding from antivirus software by making changes to themselves or their file sizes or their directory structure so they cannot be found. An armor virus is a type of virus that are designed to, they're designed and written to make itself more difficult to detect or analyze. And then you have multiple characteristic viruses that are just made up of a whole bunch of different collage of viruses, and they have a lot more capabilities than some of the other ones, and they can be pretty damaging. Then we have worms, which are mainly particular to network computers. They carry out pre-programmed attacks to jump across the network. They are self-replicating, and they do not need to attach itself to an existing program such as a virus would. And they're not nearly as destructive as viruses. They still are, but they aren't too bad. A few different types of worms that we have here are email worms. They infect through attachments or HTML links. And when you click on them, they'll lead you to a site that will infect your computer, and they'll be downloaded, and you screw up. You shouldn't have done that. Then you have IM worms, instant messaging worms, which are kind of the same thing, except it's in an instant message and not an email. We have internet worms, which they scan network resources to find vulnerable machines. They try to connect to those machines, and they will try to take them over. There are file sharing network worms, which copy themselves into a shared folder, and they appear as a harmless name. You wouldn't really think anything of it. And then when those files are spread, so does the worm. And then there's Code Red Worm, which they found it in about 2001, and it can replicate 250,000 times in 9 hours. And in 2001, it was anticipated to shut down the entire internet, but when they researched it more, they found out that it wasn't nearly as bad as it predicted. Trojan horses, they hide malicious intent inside the host program that appears to be reliable or useful. I'm sure we all know, about Trojan horses and stuff. They can cause problems such as crashing a computer, the infamous blue screen of death. They can steal money electronically from you. They can steal data, and they can download unwanted files just to make the problem worse, because that's what they do. A few different types of Trojan horses that I found. There are remote access Trojans, which are the most common and the most dangerous. They run invisibly, to gain control of the host PC and just to cause more problems. There are anti-protection Trojans, which are designed to disable firewalls, as well as antivirus software, and also filters. There are destructive Trojans, which are instructed to automatically delete core system files in an operating system. And then there are also data sending Trojans, which remit critical data such as your passwords, any credit card information, bank accounts, back to the hacker so that they can gain control of your personal information. Then we have trapdoors, which are a secret entry point into a program that allows someone that is aware of the trapdoor to gain access without having to go through all the problems of trying to figure out your security and all that stuff. They can just walk right in. And this pretty much allows anybody who has any basic knowledge of how to do this to circumvent your security measures, and they can just get your stuff, no problem. Let's see. And when they do that, they will most likely cause damage to the host, any kind of programs you have on there, or the operating system itself. You then have logic bombs, which I'm sure a few of us know about. And these are codes that are inserted to a software system that set off malicious functions when certain conditions have been met. You press a certain key, or you go into a certain program that'll start up. And when they're set off, they can perform some actions such as reformatting the hard drive, deleting data, altering data, or corrupting data itself, which is a big no-no. We have zombies, which is pretty cool. A computer that has been compromised by a hacker, computer virus, Trojan horse, anything that has been used for malicious activity. They are mainly used to spread spam to other computers so that it can just keep continuing, and there'll be more effects. In 2005, as it says up there, about 50 to 80% of all spam was sent from a zombie computer, which is pretty terrifying. And then I have a picture here, which is kind of everything that I've gone over. You have your malicious code, and then it branches off into two things. Programs that need a host, such as trapdoors, logic bombs, Trojan horses, and viruses. And then you have independent malicious code, which is worms and zombies. And as you can see, that the viruses, the worms, and the zombies can self-replicate and just expand and cause more problems. Any questions?
One question, out of your research, which one was the most, did the most damage maybe? Did any pop out?
It was definitely between viruses and Trojan horses, because there are many different viruses which can do a whole bunch of stuff, or Trojan horses because they can't be found very easily, and they can do a lot of damage before you even know that they're there.
Okay.
But it would be between one of those two.
All right.
Sure.
Let's give him a hand. Good job. Okay. Make another round up. We'll get ready for the next presenter. I'm supposed to make an announcement about fall semester. TCP/IP is up next. Fall semester classes. If you've not yet enrolled for fall semester classes, please do so. Advisors are ready on campus if you need help with it, registering for classes. I'll announce one of mine is CIS 280. The iOS development course was just approved for iPad minis for the course for all students. We have that class actually teaches you how to create iPad and iPhone applications. This next semester we're going to focus on about 3 or 4 businesses and creating apps for businesses in the real world. And students will be creating apps for businesses to use in a real world scenario. And so if you're interested in that, I do have up here tonight prereq waivers, because some of you might not have CIS 180 or 276 under your belt, because it does require some programming logic. And if you're good at math or you're good at solving puzzles, you'll like programming. If you're not good at math or not good at solving puzzles, you probably won't like programming. But if you like both of those and you're good at it, because that's what programming is all about anyway, just figuring how to do something and keep doing it until you get an app created. So if you're interested, before you leave tonight, I can give you a prereq waiver for that class. It will fill up pretty quickly, especially since I started announcing 2 days ago about the minis being available for those that register. I'm guessing it'll fill up pretty quick here in the next week. So, but I'm trying to tell my students that I have in class about this before I promote it even more. They're going to push up promotion on that more, I think, Monday of next week or something. So, but if you're interested, come and see me before you leave tonight, and be more glad to give you more information. Yep.
Okay, if there's any veterans in the classroom, or if you know of any veterans that's going to be registering, they can go over in the student center in the counselor's office and see Tom Jackson. He is one of the counselors that is sort of trained or set in to deal with the veterans for the registration of classes and help pick out classes.
Okay. So his name's Tom Jackson.
Tom Jackson.
Okay. All right. Let me see here if we got.
He is a veteran.
All right. Okay, let's go ahead and do the TCP/IP presentation. Let me get it to this one here. Hang on just a second. Okay, it's all yours, sir. There you go. Yep. And then point it towards the computer.
So what I'm doing is TCP/IP, obviously, but anyway, I'm gonna say TCP/IP a lot because I don't know why I just happened to use this word quite a bit for both my essay and presentation, so it'll feel pretty awkward. So bear with me for a while. It's TCP/IP is a computer's communications protocol, and it's used by about almost every computer in the world or any application that requires internet. For TCP, it's an abbreviation for Transmission Control Protocol, and IP is an abbreviation for Internet Protocol. It first was initiated by ARPA, but ARPA was actually trying to do something else, which involves using the processor of another system, so they can boost up what they're doing. Kind of like if they needed more power, they try to borrow a processor from another computer or another system that may be strong enough. But instead, they failed it, and instead the results were TCP/IP. And the thing was, it wasn't their priority. They were able to send messages to other systems, but they weren't really interested in that. So what uses it is just about everything on the net, like your browser and your emailing Yahoo and Gmail or AOL email. And IP addresses and domains also use TCP/IP. TCP uses a fixed connection, and what that means is one computer would send a signal or request to access the other system, and if that system if the system accepts it, then they'll have a connection to each other, which is like full duplex. And what that means is that the connections are set up simultaneously, and they'll be sending data to each other at the same time at all times until somebody closes it off. IP is used for communication between computers directly, and it's unreliable, but like I said, it lets you send data directly from the computer, and that's what TCP is there for, to help send data reliably. It is responsible for routing packets and receiving packets. It uses IP. It uses a IP address, which is 4 numbers with 3 digits each. And there's an example of one on there, and that's an IP that would route you back to the local system. And these TCP/IP addresses are called domain names. It's kind of like Google.com maybe. Each computer has an IP address. It's kind of like a personal phone number, but for some systems or some ISPs, they don't let you have a static IP. They'll give you like a dynamic IP that changes constantly, which does get annoying for gamers, and they have to port forward like every so often, just so they can let other people connect to them. And static IPs are a connection or an IP address that doesn't change, and which is what a gamer would want. They don't have to go into the router settings and forward everything. TCP/IP is basically a huge set of protocols, and a protocol is just a set of rules for what it's just a set of rules. And it uses a lot. As you see, I'm not going to name all of it off, but it's kind of mind-blowing that there's this many of them. The TCP/IP model is a lot similar to the OSI model, except it only has 4 layers, and the application layer basically makes up the first few for the OSI, and the network access layer makes up for the last tier of the OSI model. The application layer allows TCP/IP to access services from other layers below it, and it defines the protocols used to exchange data. And there are widely known protocols that we know of are HTTP. A lot of people know about this one. Transport layer is what TCP handles, and the core protocols for that is TCP and UDP. For TCP, it really lets you use a reliable communication service from one system to another. And UDP is pretty much the same thing, but it lets you connect to multiple systems, but it is pretty unreliable. For internet layer, it is responsible for addressing, packaging, and routing functions of the data packets. And protocols that it uses mainly are IP, ARP, ICMP, and IGMP. The network access layer allows TCP/IP to receive and give out packets, network packets that TCP sends out, and it assigns an address, or it is assigned an address from the internet layer, and uses the network interface devices or wires to communicate with other PCs. Are there any questions?
Nope. Let's give him a hand. Good job. Excellent. All right, make your way up to get some more. We got brownies, looks like, wings, chips, pop, pizzas. Looks like it might be gone, so that's good. If not, come up and figure it up. Apple Talk. Apple Talk's next, and let's see what we have to after Apple Talk. Let me see if I can pull it up there real quick. Oh, you got yours?
Yeah, mine is, I put it, it's
It's on there?
zipped, yeah,
Okay.
it's called Contemporary.
Okay.
It's a zipped file. I just added it.
Okay.
Google's making more annoying.
Do what?
Google's making more annoying ads now. This is scary.
Okay, there's nothing in that. There's nothing in that one. There's nothing in the drive. I don't have anything in that drive, the one you just gave me.
You know,
It's empty.
USB drive?
Oh, it's loading. I'll take it back. It's taking forever.
Keep drilled, right?
Like, it did look like nothing, didn't it?
It did.
I've been trying to save stuff off my computer, so.
Okay.
Huh? There's so much stuff.
I'm gonna go give you that. All right, it's all yours.
So I chose Apple Talk because I started using Macs a couple years ago and really like them, but know jack crap about the Mac networking. So figured it was as good a topic as any. So Apple Talk is a proprietary suite of networking protocols developed by Apple for their Mac computers. Included a number of features that allowed local area networks to be connected with no prior setup or the need for a centralized router or server of any sort. Connecting together Apple Talk equipped systems would automatically assign addresses, update the distributed namespace, and configure any required internetworking routing. It was essentially a plug-and-play system. It was released for the original Mac in '85 and was the primary protocol used by Apple devices through the '80s and '90s. Apple Talk support was also available in most network printers, some file servers, and a number of routers. The rise in popularity of TCP/IP in the '90s led to a re-implementation of most of these types of support on that protocol, and Apple Talk became unsupported as of the release of Mac OS X version 10.6 in '09. Back to '83, in January, Apple invested a considerable effort in the development of the LAN system for machines known as AppleNet. These ran on a custom 1 megabit coax system and was introduced at the target price of $500 for plug-in AppleNet cards for Macs. At that time, early LAN systems were just coming into the market, including Ethernet, Token Ring, and ArcNet. Although Ethernet's widespread acceptance indicated it was to become the industry standard. 4 months later, AppleNet was canceled. At the time they had announced, Apple realized that it's not in the business to create a networking system. We built and used AppleNet in-house, but realized that if we had shipped it, we would have seen new standards coming up. So they announced they would instead be supporting IBM's Token Ring. During this time, Apple was deep in development of the Mac, and the engineers decided to use a serial controller chip that would support a number of basic networking protocols and would allow multiple devices to be attached to the port. Then peripherals with similar chips could communicate, eliminating the need for more ports on the back of the machine, and allowed for the elimination of expansion slots for supporting more complex devices. This concept was known as Apple Bus, and envisioned a system controlled by the host Mac, pulling dumb devices, similar to the modern USB. The Mac team had already begun work on what would become the LaserWriter, their printer, and considered a number of other options of how to share these machines and other resources. At this point, printers were still expensive resources, so it made sense to share it instead of having one per person. By late '83, it was clear that the Token Ring would not be ready in time for the launch of the Mac and might miss the launch of these other products as well. So when AppleNet was canceled, Apple devs led an effort to develop a new networking system based on this Apple Bus hardware. This new system would not have to conform to any pre-existing preconceptions. It would be designed to be worthy of the Mac, a system that was user installable, had zero configuration, and no fixed network addresses. A true plug-and-play network. By the time Mac was released, the basic concepts had been outlined, and some of the low-level protocols were on their way to completion. This new Apple Bus was announced in early 1984, allowing direct connection from the Mac through a small box that plugged into the serial post and connected via cables to the next computer upstream or down. When the new Apple Talk shipped in early 1985, it included a speed of 230.4 kilobits, 1,000 feet max distance, and only 32 nodes per LAN. The entire networking stack required only about 6 kilobits of RAM. The addressing system allowed for expansion to 255 nodes in a LAN, and using bridges, one could interconnect LANs into larger collections. Zones allowed devices to be addressed within a bridge connecting internet. Additionally, AppleTalk was designed from the beginning to allow use with any potential underlying physical link. The AppleTalk network cabling used a single common electrical ground which limited speeds to about 500 kilobits, but allowed one conductor to be removed. This meant that common 3-conductor cables could be used. Also, the adapters were designed to be self-terminating, meaning that nodes at the end of the network could simply leave their last connector unconnected. There's no need for wires to be connected back together into a loop, or a need for hubs or other devices. To join an existing network, one simply plugged in the adapter and connected a cable to the nearest free machine. AppleTalk was so easy to use that ad hoc networks tended to appear whenever multiple Macs were in the same room. Apple later used this in an ad showing a network being created between 2 seats in an airplane. By '87, Ethernet was winning the standards battle over a token ring, and in the middle of that year, Apple introduced EtherTalk for the Mac II. The package included a new bus, NUBUS, a 32-bit parallel bus card with Ethernet ports, and a new network control panel that allowed the user to select which physical connection to use for networking. The releases a new networking stack, which also expanded the system to allow a full 255 nodes per LAN, and then AppleTalk was renamed to LocalTalk. The appearance of EtherTalk also led to a potential issue. Networks with new and old Macs together on the same network needed some way to communicate with each other. This could be as simple as an Ethernet Mac 2 trying to communicate with an old LaserWriter printer. So a significant redesign was released in '89 as AppleTalk Phase 2. LANs could now support more than 255 nodes, and zones were no longer associated with physical networks but were entirely virtual constructs used simply to organize nodes. For example, one could now make a printer zone that would list all the printers in an organization, or someone might want to place that same device in the second floor zone to indicate its physical presence. Phase 2 also included changes to the underlying internetworking protocols to make them less chatty, which had previously been a problem on networks that bridged over WANs. Ethernet had basically become universal by 1990, and then they decided it was time to build Ethernet into Macs direct from the factory. So the physical wiring used by these networks was not yet completely standardized, so Apple solved this problem using an Apple bus-like solution, having a single port on the back of the computer into which the user could plug an adapter for any cabling system that they had. This FriendlyNet system was based on the industry standard attachment unit interface, but they deliberately chose a non-standard connector that was smaller and easier to use, which they called Apple AUI. FriendlyNet was first introduced on their Quadra 700 and 900 computers and used across much of the Mac line for some time. As with LocalTalk, a number of third-party adapters quickly appeared. As 10BASE-T became the cabling system for Ethernet, second-generation Power Macs added a 10BASE-T port in addition to the Apple AUI, and eventually dropped the AUI altogether. In '88, they released Mac TCP, a system that allowed the Mac to support TCP/IP on machines with suitable Ethernet hardware. However, this left many universities with a problem of supporting IP on their many LocalTalk equipped Macs. So Stanford University pioneered the development of Mac IP that allowed IP packets to be routed over LocalTalk networks with the support of a suitable gateway machine. These were initially custom devices, but it was soon common to include such support in a LocalTalk to Ethernet bridge. And Mac TCP became a standard part of the Mac OS in '94. For some time in the early '90s, the Mac was a primary client on the rapidly expanding internet. Through this period, Macs had about 2 to 3 times as many clients connected to the internet as any other platform, despite the relatively small overall market share. With development of OS 10, AppleTalk was strictly a legacy system, and support was added to OS 10 to provide support for a large number of existing AppleTalk devices, especially the laser printers and file shares. But alternate connection solutions common in this era, notably USB for printers, limited their demand. As Apple abandoned many of these product categories and all new systems were based on IP, AppleTalk became less and less common, and as was mentioned before, was finally removed from the OS in version 10.6. The AppleTalk design followed the OSI model of protocol layering. Unlike most of the early LAN systems, AppleTalk was not built using the Xerox XNS system. It contained two protocols aimed at making the system completely self-configuring. The AppleTalk Address Resolution Protocol, or AARP, allowed AppleTalk hosts to automatically generate their own network addresses, and the Name Binding Protocol was a dynamic system for mapping network addresses to user-readable names. Although systems similar to AARP existed in other systems, nothing like NBP had existed until recently. Both AARP and NBP had defined ways to allow controller devices to override the default mechanisms. The idea was to allow routers to provide the information or hardwire the system to known addresses and names. On larger networks where AARP could cause problems as new nodes search for free addresses, the addition of a router could reduce the chattiness. Together, AARP and NBP made AppleTalk an easy-to-use networking system. New machines were added to the network by plugging them in and optionally giving them a name. The NBP lists were examined and displayed by a program known as the chooser, which would display lists of machines on the local network divided into classes such as file servers and printers. When AppleTalk was first introduced, the dominant office computing platform was the PC compatible running MS-DOS. Apple first introduced the AppleTalk PC card in early '87, allowing PCs to join AppleTalk networks and print to LaserWriter printers. A year after that, AppleShare PC was released, allowing PCs to access AppleShare file servers. The loss of AppleTalk did not reduce the desire for networking solutions that combined its ease of use with IP routing. Apple has led development of many such efforts, from the introduction of the airport router to the development of the zero configuration networking system and their implementation of it, Bonjour. After its introduction in '02 with OS 10 version 2 as named Rendezvous, the software was renamed in '05 following an out-of-court trademark dispute, Bonjour. Zero Config is a group of technologies that includes service discovery, address assignment, and hosting resolution. Bonjour locates devices such as printers, other computers, and services that those devices offer on a local network using multicast domain name system service records. The software comes built in with OS 10 and iOS operating systems. Bonjour can also be installed onto computers running Microsoft Windows. Bonjour components can be included within other software such as iTunes and Safari, and a host of other ones. Bonjour is widely used throughout OS 10 and allows users to set up a network without any configuration. iTunes uses Bonjour to find shared music. iPhoto uses it to find shared photos. Some of the other programs that use it, iChat, Adobe Creative Suite 3, Proteus, Adium, Pigeon, Skype, Vine Server, iTV, TiVo, they all use Bonjour. It only works within a single broadcast domain, usually a small area, without special DNS configuration. Mac OS 10, Bonjour for Windows and airport base stations may be configured to use wide area Bonjour, which allows for wide area service discovery via an appropriately configured DNS server. That can all be found in Wikipedia. Any questions?
No, Nick, give Bert your hand. Good job. All right. All righty. Let's see here. Let's go to Prezi. Prezi presentation. Let's come up and get some more stuff.